Hi, and welcome back to Fundamentals of Engineering with Mechanics of Materials, modulus of elasticity. In this example, we have like a rod which happens to handle a tensile force at both ends and elongate in the x direction and decrease in diameter in y direction. So length increased and diameters decreased. So in our example, a test specimen with a circular cross-section has a length of 500 millimeters and a diameter of 16, initial length of 500 millimeters and initial diameter of 60 millimeters. Then a 50 kilonewtons force applies at both ends, and then the specimen has a longitudinal elongation of 0.60 millimeters and lateral decrease in diameter of 0.01505 millimeters. We want to calculate the modulus of elasticity. To start such problem, first of all, calculate the stress in the direction of the force. So tensile stress sigma sub x is equal to force over the area of the initial area of the specimen, and that's force is 50 kilonewton. That's 50 times 10 cube newton over pi times 60 millimeters squared over 4, which is 6 centimeters squared over 4. And if you do the math, it gives you a stress in X is equal to 17.68 megapascal. As soon as we have the stress, then we can jump to the strain formula. So strain in X is the elongation in X direction over the original length, which is 500 millimeters in problem statement over here. So the elongation is 0.16. Elongation, longitudinal elongation is 0.60 millimeters over 500 millimeters. It just gives us 3.2 times 10 to negative 4 millimeters over millimeters. As soon as we have that, based off Hooke's law, we can jot down the epsilon x in a 2D plane, 1 over e in parentheses sigma x minus nu sigma y. So because we don't have any stress in y direction, this part goes 0. We are looking for modulus of elasticity. We already have our epsilon x, so the only unknown in our equation is E, or modulus of elasticity. So it says if we rearrange our equation, rewrite our equation, epsilon x is equal to 1 over modulus of elasticity times a stress in x direction. And by having the numeric value replaced in the equation, the only unknown is E. And if you do so, it just gives you modulus of elasticity is equal to 55 times 10 to 9 Pascal. Let's see the deformation of our circular rod. So you can easily see the original shape was the white one, and then it just decreases in length in the yellow shape and decreases in diameter. So we have like epsilon y and epsilon x. You can easily see epsilon y elongation in y direction is decreasing. That's why we have a negative. And epsilon x is a positive, that's elongation in x direction. But the problem is just asking for modulus of elasticity, which we already calculated, and that's choice number C. Thank you. We'll solve more problems.